We looked at the structure of the atom and also at isotopes. Now we're going to look at the electronic structure of the atom. The electronic structure is how the electrons are arranged in the atom. Now, previously I told you that electrons occupy energy levels or shells around the nucleus, and they do this in a very structured way. And the periodic table helps us understand that structure and that arrangement. Now, elements are arranged in the periodic table in increasing atomic number. And the atomic number tells us the number of protons in the nucleus, but it also tells us the number of electrons. So for example, oxygen here, which has symbol O, has atomic number 8, and that means it's got 8 electrons. Another way the periodic table is arranged is that it's arranged vertically into groups and horizontally into periods. So we have group 1 from the left, and then group 2, and we miss that rectangular block in the center, and then we have group 3, 4, 5, 6, 7, and then group 8, also known as group 0. And horizontally we have the periods, so period 1 all the way down to period 7 at the bottom there. Now let's take a look at the first element, the smallest element, which is hydrogen. Hydrogen has atomic number 1, so it's got 1 proton in the nucleus, and it also has 1 electron. It doesn't have any neutrons, so it's going to have electronic structure of 1. Then we look at the next biggest element, which is helium, and in the periodic table it is drawn in the right hand side, so I'll draw it there as well. So it's got atomic number 2, so 2 protons, also 2 neutrons, and it'll have 2 electrons. So its electronic structure is 2. Now I'll draw a section of the periodic table out for you just to show you where each element is in the periodic table. So hydrogen is there at the top on the left hand side, and helium there on the right, and they are both in period 1. Now let's move on to period 2, from lithium to neon. So lithium is the next biggest element. Now I'm not drawing the protons and the neutrons anymore, and just the electrons. So it has atomic number 3, so 2 electrons will occupy the first energy level. Now 2 is the maximum number of electrons that can fit in that first energy level, and it has there's another electron, so that other electron now has to occupy a new energy level, and so we draw it in another shell. So its electronic structure is 2, 1. Then we move on to beryllium. Now beryllium has atomic number 4, so we have to fit 4 electrons, maximum of 2 in the first, like so, and then 2 electrons in that new energy level, 1, 2. So its electronic structure is 2, 2. We can move on to the next energy level, boron. Next element, boron has atomic number 5, 2 in the first, and then 1, 2, 3 in the second energy level. Electronic structure 2, 3. Now we can move on to the next element, carbon. So 2 in the first energy level, and 1, 2, 3, 4 in the second energy level. Electronic structure 2, 4. Now notice how I'm filling in the energy level that is closest to the nucleus, the shell, and then moving outwards. So that's very important to follow this, because the energy level that's closest to the nucleus is the one that's got the least energy, and it's more stable. So that's how electrons will fill. Now let's move on to the next element, nitrogen, atomic number 7, 2 in the first, and then 5 in the second. So 1, 2, 3, 4, and this is where we start pairing up. So the fifth one will pair up with one of the electrons. So it's got an electronic structure 2, 5. Now it's very important that we fill in electrons like this. Thus after 4 electrons we start pairing up, and this is important when it comes to bonding. Let's move on to the next element, oxygen, 2 in the first, and then 1, 2, 3, 4, and then start pairing up 5 and 6. So we'll have 2 pairs of electrons and 2 single electrons. 2, 6 is its electronic structure. Then we move on to fluorine. We'll have 2 electrons in the first, and 1, 2, 3, 4, 5, 6, 7. So 3 pairs of electrons, 2, 7, and then neon, which is the last element in this period, 2 in the first, and then 8 in the second energy level. So 4 pairs of electrons. 2. So 2, 8 is its electronic structure. Note that the maximum number of electrons in the second energy level is 8. Now I'm going to move on to the third period, from sodium to argon. Now sodium is in group 1, and so I'm going to draw it just underneath lithium, also in group 1. It's got atomic number 11, so 11 electrons. The first 2 electrons will go in the lowest energy level, 2 in the first, and then we'll have 8 in the second. So I'm going to have 1, 2, 3, 4, and now I start pairing 5, 6, 7, 8. Now it needs another electron, so this new electron will occupy a new energy level. So we'll put it there. Its electronic structure is 2, 8, 1. Now let's move on to magnesium. Magnesium has atomic number 12, so 12 electrons. So 2 in the first, maximum of 8 in the second, and then we have to fill in 2 in that third energy level. So its electronic structure is 2, 8, 2. Now you can pause the video and fill in the electronic structures of the rest of the elements in period 3, from aluminium to argon. I will fast forward the video so you can check your answers. Note that 8 is the maximum number of electrons that you can have in the third energy level. Now there are a couple of patterns that we notice, and that is the elements that are in the same group have that number of outer shell electrons. So for example, lithium and sodium are both in group 1, so both have 1 outer shell electron. Beryllium and magnesium are both in group 2, and they have 2 outer shell electrons. So this pattern continues across the period all the way up to group 8 elements, which will have 8 outer shell electrons. Now there is another pattern that we also notice, and that is that elements are arranged in periods. And so elements that are in the same period, for example hydrogen and helium, are in period 1, have electrons that occupy 1 energy level. And similarly, group 2, period 2 elements from lithium to neon will have electrons that occupy only 2 energy levels, and period 3 elements will have electrons that occupy 3 energy levels. So you can use the periodic table as a grid reference to quickly draw out the electronic structure. And I'll explain what I mean by this with an example. So looking back at the periodic table, we'll take an example of potassium, which has symbol K, and atomic number 19 is in group 1 and period 4. So that means it's going to have 19 electrons, and it's in period 4, so it'll have 4 energy levels, 1, 2, 3, 4, and it's in group 1, so that means it will have 1 outer shell electron. And now the rest of the energy levels are full, so we'll have a maximum of 2 electrons in the first energy level, a maximum of 8 in the second, and another maximum of 8 in the third, and the electronic structure of potassium will be 2, 8, 8, 1.